We'll start right away. So today, in the earlier session, we talked about the optimization of marine fleets, marine logistics, and a lot of good presentations you have listened to. But the current one will be decarbonizing logistic value chain. A very, very important topic about energy transition, decarbonization, and we have three eminent speakers. Mr. Tanuj Sharma from Invest India is here. Mr. Thomas Philip from the Salt System is here. And Mr. Christoph Kopp will be joining shortly from Exmar. So we'll have three presentations. And before we hand over mic to Tanuj, just to set the context, uh, I want to tell you some of the numbers. So currently, globally, 80% of the world trade is happening by sea route. Very important number. So as per the IMO study, the marine logistics account for 2.8% of global greenhouse gas emission. It is 2.8% of GHG emission comes from the marine logistics. And the IEA report I have seen, 2022 IEA report, says that the CO2 emission from the marine logistic operation has increased from 500 million ton of CO2 in 2000 to almost 700 million ton of CO2 in 2022. So just within 20 years, it has increased from 500 to 700. This is because the marine operations are increasing globally, the number of fleets are increasing, but very important target set by IMO, net zero by the marine industry by 2050. So it is not very far, 25 years from now, the marine industry has to become net zero. So if you're coming back to Indian context, I think in the last presentation, we talk about the Harit Sagar, the Ministry of Shipping launched one document in 2023, putting a very challenging task to the marine industry in India, where they are telling the reduction of carbon intensity by 30% per ton of cargo handled by 2030, and it should be 70% reduction by 2047. So very challenging task by the port and marine industry in India. There was another important document, the Maritime India Vision 2030, again by the government in 2021, which actually talks about 150 initiatives for strengthening the maritime sector. So some of the very interesting number in Hajit Sagar, that green belt area, actually India you have some major ports, minor ports, inland waterways. So a large number of coastline, 7,500 kilometers of coastline India has, and the tremendous opportunity for growth of marine industry here. So port will target electrification of vehicle and port equipment to about 50% by 2030, and 90% of all the port equipment has to be electrified by 2047. Very, very challenging task. All major ports will establish EV charging stations by 2025, LNG bunkering station by 2030, and green ammonia bunkering station by 2035. These are targets given by the government. And as I have been told that from shore to ship power has to be done by 2025. Of course, it is not possible. One or two ports have already done. So it has been shifted to 2030. So what the problem marine industry is facing nowadays for decarbonization, what they are doing. So there are multi-pronged strategies. People are adopting alternative fuels like LNG, ammonia, methanol, hydrogen, biofuel electrification, using digitalization, big data, AI, blockchain to increase efficiency, fleet management, route optimization, and emission reduction. Use of energy efficient technology like wind assisted propulsion, capturing CO2 or CCS, and all electric vessel. Then reducing waste, circular economy in terms of reducing waste, reusing material and recycling of resources such as ship recycling. Then a lot of collaborative efforts are happening, like Global Industry Alliance for Maritime Biosafety. So a lot of things are happening, and marine industry has taken as a challenge the IMO target to become net zero by 2050. And in India also, the Ministry of Shipping is coming up with regular some documents, initiative, strategies to help the marine industries and Indian ports to adopt this net zero. So without taking much time, I will invite Tanuj Sharma, Senior Assistant Vice President Invest India. His topic is Green Ports, the conceptual framework towards decarbonizing port operation. Just give a brief biodata of Tanuj. Tanuj is working in Invest India as Senior Assistant Vice President Oil and Gas, more than 17 years experience in energy sector, in research consulting, business analysis, planning, PLL management, accounts management, and he has exposure in working in conventional energy as well as new energy, including transition. So the Anuj, the floor is yours.
Thank you, sir. Good afternoon, everyone. Uh, the concept of green ports, before we talk about that, let's understand that we have seen a lot of investments in renewable energy. We see solar, we see wind, onshore, offshore. We see LNG and natural gas as very well accepted fuel of energy transition. But all these fuels are operating in isolation, independent of each other. What will happen if all these fuels can be brought together, even EV, even BESS, and they can operate at a single place together and understand the dynamics that they can play? That is where green ports come into the picture. So one important application where the green fuels can be brought together, including green molecules like green hydrogen, all the other green liquid fuels, they can do wonder in the port applications, in the shipping and marine industry. Importantly, for a lot of companies, the shipping will constitute the scope 3 of emissions, which is difficult to audit and difficult to account as well. But if we can bring together all the green fuels together at the marine and port operations, this can be very useful for all the economies. So if we see at the ports, what are the sources of emissions? This would include the vessels, which are the ships, small ships, large ships. We know there are Panamax, there are VLCCs, there are VLGCs, very large ships, and they consume conventional fossil fuels to operate. Then there are harbors, there are marine vessels, there are coast guard vessels. These are the seafaring vessels. If you see the equipments at the port, they also consume electricity. They also lead to a lot of fossil fuel emissions, which is the cargo handling equipment. Lot of work of loading, unloading cannot be done without cranes. So they also consume electricity. And then there are direct consumption of utilities in terms of water, in terms of electricity, power, natural gas. Then all the vehicles which are connected with the port operations, be it trucks, be it railway locomotives, heavy duty vehicles, commercial vehicles, employees, all these constitute a very high concentration of emissions at the ports. There are evidences which suggest that globally, wherever the density of port operations is very high, the localized pollution, carbon emissions are so high that people are having infections in lungs, and the mortality rates are very high. And if you see the kind of emissions, whatever emissions we have been hearing so far, all of them you get to see at the ports. Not only this, beyond the atmospheric damage, we also do damage in terms of water. We also do damage in terms of the waste management and also the building waste. Oil spent is also there. That is how the concept of green ports come into the picture. That is a well thought plan by the government that maximize the benefits of global trade, which will continue to grow for India and also for many countries and many companies alike. And if we can plan long-term decarbonization, the idea is only one tool of renewable energy is not enough. Only solar is not enough for decarbonizing the port operations. Wind is not enough. Natural gas alone is not enough. We need to pick up points wherein we can implement different fuels, different elements of renewable energy, and we can plant, we can seed those elements in various port operations. That will lead to a lot of change in the fuel mix, be it power, be it fuel, be it even solid waste management and even water management. Shore power, we were discussing, one gentleman were discussing just before this presentation as well. Now the idea is to shift various fuels. So initiatives have to be there in terms of the fuel shift based as well as non-fuel initiatives, which can have concentration of various technologies in terms of solar, offshore wind. We can do electrification of various equipments. We can bring about LNG, CNG. We can also talk about electric vehicles, and we can very safely talk about green hydrogen derivatives, something which seems quite expensive now, but there are countries, there are companies which can absorb green hydrogen as a fuel in the ships. Also, India can export green hydrogen and green ammonia derivatives to several countries. Non-fuel based initiatives which will lead to cleaning the port operations would include increase in the green belt, handling the water and waste much better, doing a lot of rainwater harvesting as well. And not to say energy efficiency will continue to play a major role in the energy transition pivot. Now these implementations, they have to be taken up at the major ports first, and then we look at other ports. So in major ports, the phase one, as Sina sir has also spoken about, the phase one is at 2030. A lot of initiatives have to be implemented and fructified by 2030. And phase two will see all these initiatives maturing by 2047 as well. Now, how these different fuel shifts can do wonders. Let us talk about LNG. LNG can be used as a fuel for the trucks that operate at the ports. In fact, China has a lot of them. So we would need the infrastructure requirement of LNG stations, LNG bunkering stations. We can have ships operating on LNG as a fuel. We already have LNG cruise ships, means cruise ships which take shorter distance like Mumbai, Goa types, Andaman types. Not in India, but yes, they can take LNG as a fuel as well. For this, in terms of infrastructure requirement, we need at least truck to ship refueling, we need LNG bunkering, and if not, we would need LNG storage tanks at various major ports. So they can take LNG from various RLNG terminals in India, Dahej, Hazira, Dabhol, Mundra, and then using the truck loading bays at LNG terminals, trucks can bring LNG at various ports, and that is where the truck to ship refueling can be done. In terms of electric mobility, we can see various vehicles at the ports. They can shift to e-mobility. We can have some equipments operating at the ports in terms of cranes and forklifts. We have relevant examples so far. We can also have cruise ships operating on electric mobility. For this, we would need the infrastructure investment in terms of dedicated EV charging stations. That is where the role of solar and wind also plays importance, because solar can be used to power the e-mobility battery charging stations, as well as wind can play that role. But more importantly, solar and wind can also play the role of shore power. So shore power, as one gentleman was speaking, is something that a ship will use power when the ship is docked at the port and is not mobile. So even during those times, the ship would need power to run its a lot of equipments and operations, loading, unloading time. Shore power is that power which the ship will consume during that time. The idea is a lot of ships can take that power from the port side and not burn their conventional dirty fossil fuel. However, there is a limitation in shore power, is that a lot of ships can take shore power from the shore side. For example, container ships, ships like ro-ro ships, they can take shore power. But various ships which are into the business of chemical liquids, and they can be volatile chemical liquids, they are still not in a position to absorb shore power from the shore side because of all the changes required in terms of standardization of the equipments and voltage, frequency, current, shock absorbers, circuit breakers. If by chance any single fault happens, the entire chemical ship can burn. So shore power is possible, it is feasible, but all ships cannot take shore power. So still the container ships can shift to shore power and stop burning their conventional fossil fuel, and that is where solar and wind, they come into picture. So offshore wind farms in the sea areas, we can see we have a lot of them in the North Sea area. These implementations, they can bring about a change in the shore power. That is where another green fuel, which is green hydrogen, which is now the talk of the days. Everybody is talking about green hydrogen, green ammonia, green methanol. These fuels can be helpful for fuel cell based applications in forklifts. They can also help the navigation system of the ships once we have the fuel cell based navigation equipment in the ships. And green hydrogen can be a good bunker fuel as well. And a lot of export possibilities exist for green hydrogen and green ammonia. And for that, the infrastructure investments have to take place at the port themselves. So once we have the green hydrogen derivative based investments and changes done at the port side, we can see the green hydrogen and the green hydrogen derivatives doing wonderful job at the ports. Because as of now in India, we can say that green hydrogen derivatives, they have more future in terms of exports than the captive and domestic consumption. So this slide shows how different fuels, which are cleaner fuels, they can operate at a single place for the common good of all, a lot of companies and lot of countries, and they can help combat the ship and marine based logistical pollution. If we see the guidelines given in the green ports policy, then the two target timeframes are 2030 and 2047. The first and the easy part to do is renewable energy in terms of solar and wind. So renewable energy consumption at ports, it could be captive, it could be grid imported as well. So not that you have to fill up all the port land with the captive solar power generation. So 60% of power consumption at ports has to be done through renewable energy sources by 2030. It will go up to 90% by 2047. Then electrification of port equipments, 50% is the target for major ports by 2030. That is an uphill task, but it is doable because we do have lot of battery charging stations throughout our country which handle the commercial loads, which handle also the buses. This is a possibility. We just need to take our electric charging station at the port side. Then LNG bunkering station, of course we need one at least at each major port by 2030, and I think a lot of job will be done by one LNG bunkering station. The volume, the capacity will have to be worked out given the type of ships that dock at the ports. Then we need to have green hydrogen and green hydrogen derivative bunkers and refueling facilities. These can come up by 2035, being price prohibitive as of now, and the way hydrogen will behave, the metallurgy of the equipment that will be required to hold it, either in the liquid stage or in the gaseous stage or simply in the form of the fuel cells. This will be studied, but yes, there are mandates, there are policy indicators that green hydrogen and derivative facilities have to be there by 2030 as well, 2025. EV charging stations need to be there in the current year. So this year we should hear a lot of news on EV charging stations coming up at major ports. These are the investments need to be done in terms of fuel mix changes, and what this can lead to is carbon reduction in terms of the cargo handled and in terms of the voyage being taken up by the ships. Green belt area investments will also have to be done. Of course, I understand several ports are old. Their land area would have been occupied majorly by the equipments, by the movement of vehicles and creating pathways for movement of vehicles and also men and material. But yes, green belt area has to come up 20% by 2030 and 1/3 by 2047. Now let me share some examples in India that we have on all the initiatives, but they are spread across and not concentrated at a single place. Offshore wind, we have the VO port. It is selected for a pilot project on offshore wind farm. So again, you see offshore wind and it is connected to a port area. Then we have green hydrogen based boats operating in Cochin shipyard. They have been developed by Cochin shipyard. We have LNG stations as of now focusing on long distance trucks. There are a lot of companies operating LNG stations. You can meet those companies in the IEW. And we have renewable energy based power and e-mobility at ports. Vizag port is doing major interventions. We have a green hydrogen hub in Andhra Pradesh as well. This is interesting. These are some examples worldwide as to how these green initiatives have been implemented at various ports. You can see a lot of ships and port areas. So we have LNG tugboats. We have green hydrogen fuel cell boat in India. We have LNG tugboat in Australia. We have LNG truck loading bay in China. You can see the number of trucks being docked there. We have hydrogen forklifts in Denmark. We have Port of Amsterdam. You can see there are solar rooftop panels. We have e-mobility applications in USA as well. So if it can happen at a scale in a lot of places in the world, we can do that in India as well. This is a ship which is fueled by LNG. It was used by Tata to bring coal from Australia. So the ship was literally empty. It was on water ballasting when it went from China to Australia. That time it was operating on LNG. When the ship brought coal from Australia to India, then it was partly operating on LNG plus the conventional fuel. So the company says the carbon emissions are one third less compared to conventional fuels, and more such ships you will see Tata plying on the this route to import coal. So this is something which an Indian company is doing. LNG fueled cruise ships can be a good reality, can be a good possibility. There are global case studies available. We have the central picture you see is from the Disney Group, which we see in the film industry. So they have a cruise ship operating on LNG. We have other ships. So LNG refueling is possible. LNG based cruise ships are possible. And the right hand side picture you see is a ship operating as an icebreaker, which is operating on LNG. So you can imagine the extent of distance these ships can still travel, still operating on LNG. However, LNG, though good fuel and a very clean fuel, it gives you lesser carbon emissions. There are still some cons in this because the LNG fueling stations are not present globally. So that intervention has to be there, investments have to be there. Coming up with less energy volume, we would need to understand that the tankage area would need to be broader for LNG, and engine change would also be required. That's all, ladies and gentlemen, from my side. Thank you so much. Thank you.
Thank you, Tanuj, for a very nice presentation. I think everybody knows the importance of decarbonizing not only the ports but the marine industry. So our next speaker is Mr. Thomas Philip, and he's from the Salt System. This presentation will be integrated fleet management for marine operation. It's just a brief bio. Commodore Thomas Philip retired as a mechanical engineer with specialization in field of design engineering from IIT Delhi and operation management from IIM Kozhikode. He has started his career 20 years as a marine engineer in Indian Navy, rich experience, and he was involved in design, operation, shipbuilding and repair, and which included indigenous aircraft carrier building project and nuclear submarine. So I think let us listen to him on his very informative presentation. Mr. Thomas, please.
Thank you, sir. It's been, I know it's a post lunch session. We are almost closing to tea time, and you guys have been a very patient audience. I think let's start with a round of applause for yourselves so that we get some energy into the hall. Thank you so much. And I'll just request that you just continue to be the hall for next another 15 minutes. So my name is Thomas Phillip. I lead the logistics sector business in resource systems. And most of you must be wondering, what is a software manufacturer doing where everybody is talking about oil and gas, everybody is talking about energy, everybody is talking about distribution. But I'm so happy to share today that I have been attending few sessions before me. A lot of discussion is happening on digital twins, on digitization of process, digitization of activities, so that we achieve the requirements of regulators that has been set as far as achieving the goals of net zero. So the intent of being here is, of course, to showcase what Dassault Systems does in the energy sector with its own clients to achieve these goals of sustainability. Having said that, it's important that we introduce ourselves. We are a 40-year-old company in the business of software. We started our journey with Dassault Aviation, which was our parent company. Started with 3D modeling of aerostructures way back in 1981. So from components, we of course moved into assembly. From assembly, moved into industry and processes. By 2012, we got into a mode of not positioning individual solutions, but to position platform as a solution, provide a unified data environment to our clients in the aspects of 3D design, simulations, data analytics, and PLM. And in 2020, learning from the aspect of COVID, we've started developing virtual twin for human beings. And of course, our goal is to provide a technology to the world by 2040, become one of the most sustainable companies in the world. Having said that, I just want to share quickly because I know it's there is only 15 minutes available to us. The different products. I'm so happy to learn that when we were walking around in the exhibition hall, many of you are actually our clients and are using our solutions, which is primarily in design and simulation. Of course, there is a large amount of activities that we can do still further together. That gets me to, of course, the topic for today, which is integrated freight management for marine operations. I come from a naval background, a subject which is very close to my heart also. So I will cover this whole aspect to cover all the stakeholders who are involved in the value chain. So we'll start with ports. Of course, the next is on the distribution side, which is primary distribution and secondary distribution and data analytics. So I will just run into the reason why we are talking all this. I think Sinasar also brought out there is a target of IMO for marine freight and marine movement to become net zero by 2050. That amounts to almost 70% reduction in carbon emissions. And this is where people like us come in by getting aspects of cost and efficiency, customer service, safety, and asset utilization and sustainable operation becomes a key element of all the freight operations that you do. Now, what I've done is, of course, we also have to tell how we approach this problem. Uh, so, at the core of the value chain lies the port. So, what we call as the port infrastructure or smart ports. I will also be my whole presentation is covering all these elements. Then, of course, is the aspect of how we can simulate a vessel transit from point A to point B. What is the kind of carbon emissions that will be generated with that kind of movement that is being planned. Of course, there is the aspect of how the vessel is scheduled for port call, and the aspect of vessel scheduling itself, and primary and secondary distribution, which is on the rail and the road side, right? So we'll just get into the business for the day. Smart ports. So what exactly is a smart port? I'm sure that a lot of aspects which Tanuj covered earlier was related to how ports can become green. What we offer is an aspect of virtual twin for ports, which is combining the data that is available today, both in terms of data on the enterprise and data on the machine side. And what do we achieve by that? To create a smart port which is going to increase the resource utilization. We know that resources in port are costly resources. Maximize the QA and the jetty utilization, crane movements, minimize non-value added movements within the port using our digital technology, and of course maximize the customer satisfaction, uh, with respect to how the turnaround of the ship happens in the port itself. So this is what we do with the ports. There are a number of references that we have in this sector. Unfortunately, because of NDA requirements, we cannot share those references here, but we'll be happy to probably host you in our booth and probably share more data on this. So what we do in ports is, of course, create the digital twin of the port for providing a visualization in the 3D environment. Now, these models are not static models. You can simulate a large number of operations in this model. Of course, once the model is alive, then you connect it with IoT and other aspects of operation onto the digital twin. Aspects of movement of containers, we know the challenges that we had with respect to non-availability of containers few years ago. We have solutions that manage empty containers and planning, something again which Tanuj covered on the aspects of energy management within the port. And we know that port is a very brick and mortar and labor intensive environment. Labor laws are very, very stringent as far as our country and of course globally it is concerned in the ports. How we can get into a solution which sort of manages this workforce so that they are effectively utilized and they remain satisfied with respect to the aspects of roastering and other activities. So this is a whole gamut of solution that we provide with respect to the digitization of ports is concerned. So moving forward, of course, I see that the large number of crowd is oil and gas. So I sort of tweaked my presentation also to cover something which might be close to your hearts in terms of oil and gas distribution. So this is what we do with respect to distribution aspect. We start with designing the network itself. It's a typical OR problem where we design the network from the start, that is the demand point and the supply point, and match the supply to the demand in the most optimal manner. Of course, once the network is designed, then we assign the hubs based on which are the points that you need to cover in that particular distribution. Then what is the kind of board that you want to use so that you not only save on cost, we also achieve your goals on the aspects of carbon reduction in that particular run. Freight consolidation, I am sure that many of you use third party logistics. How can you consolidate your freight with a single contractor so that you also amortize the effectiveness of the cost that you are spending on that particular distribution. And of course, tactical and strategic load planning, that is primarily we do large amount of forecasting for a year, which is called as a technical load planning, and going down to the day of operation when the actual operation is happening for management of disruption. And of course, I'll provide you with those analytics on the distribution system itself. So as far as the LNG sector is concerned, this is what we cover. We do a lot of sales and operations planning within the plan itself, which is on the bottom circle for LNG production. Of course, how inventory is managed within the plant and how inventory is planned at the stocking points, so that you don't end up in carrying higher costs of inventory carrying costs, or don't neither do you end up in a situation of stock out. Of course, this is the complete value chain starting from the terminal, from the refinery to the terminal, how the vessels are planned, how the pipe is scheduled, and of course the road and train. So I would, in the next slides, these are actually screenshots from our own solution. So to begin with, we start with how inventory is optimized between the supply and demand. So in terms of long term, medium term, and short term, so that as I said, you any aspect of value addition in terms of additive blending or additive sourcing, all these aspects get configured onto a solution. And the screen that you are seeing on the slide is actually from a solution that we provide to our customers. So once the inventory, that is the product that is to be moved, is managed, next activities, of course, to design the supply chain itself. When we are talking about supply chain, we start at the global level. Of course, what you saw was the map where we are sourcing globally. We come down to then your plant level, where the plant is then optimized for various activities, and then from there we come down to the product level, which could be of various formats. So we optimize at the global level, we optimize at the plant level, and then we optimize at the product level. So if you would have attended a previous session, my friend from Accenture was talking about these solutions, and our tool is primarily being used for creating those solutions, right? So what you are seeing is actually a demo from our own screens on what I am talking about on the supply chain configuration. Of course, moving forward, there are three distribution decisions which I am probably covering. One is, of course, on which is the vessel to be used, and of course, then the aspect of pipeline scheduling, and then the rail and truck. So, in terms of vessel scheduling, we start with your annual delivery or annual distribution plan. So we generally consume the forecast that you have for the year, and as you can see from the screen that of course this is a demo that is running. How we can probably plan in advance, which is the best methodology to move your product produce from the terminal to the from the refinery to the terminal, from the terminal to the final retailer, right? So once you have done this annual planning, of course, closer to the execution days, there will be aspects of distribution. So we have this optimizers which take data from different sources and run this distribution, manage this distribution either in a manual mode by simply dragging and dropping on the GUI itself, or it could be you can invoke the optimizer as required, or it can be a trigger based where the optimizer runs on a trigger and replans based on a disruption that could have happened because of a delayed ET of a particular ship, or a disruption in the plant itself, or a change in demand or a priority demand being changed from the customer side. So again, moving fast, uh, we from here, once you have the annual distribution plan, I'm sure that many of you run your own fleet. So how the fleet availability can be improved and the maintenance periods of this fleet can be managed. From there we go to the master planning of each of this vessel, and as you can see, what is it if you look at the right hand side bottom corner, uh, there's so many commas and zeros on number of possible loops as far as the optimization run is concerned. So we run this optimization run so that you get the best schedule for your sailing plan. This is again important as far as your carbon emissions are concerned. So this is something that we did for one of our clients who runs OSV vessels. So what is the cruising speed with respect to the voyage, and how it is plotted against the carbon emission. We have these tools available with us which you can probably use for your calculation of CO2 emission even before the vessel goes out to sea. Of course, then next is the aspect of pipeline distribution. Uh, how do we determine the batch sequences, determining the batch size, of course, the flow rate, the start time for the pipe to be utilized, the end time for the pipe to be utilized, and the junctions, how they are managed, can be again scheduled from the same solution. And of course, the aspect of rail tank cars. We are right now doing a very large project with the Indian Railways where we are doing route optimization and scheduling for freight trains for 10,000 kilometers for around 14 divisions. That solution is also similar to what I am showing on the screen. The same thing we can do for you. This also includes your tank cleaning requirements, the product mix as far as the rail wagons itself is concerned, and of course the aspect of road transportation, which is primarily on the aspect is to reduce the dwell time of the trucks when they come to the terminal with respect to the incoming or outbound logistics. So as you see, we also do a lot of solutioning for EV routing, because EVs become have a special consideration where we have to route it through a charging station. So we do that also, and when we do this kind of a routing, one of the KPIs is of course on the carbon emission itself. So carbon emission itself is one of the KPIs for routing these EVs. So at the end of the year, where are you with respect to your sustainability goals? You will have a very clear indication based on the planning that is done. And of course, while we talk about so much of operation, it's important also to mention that when we plan a maintenance for any of your assets, which is the best window to do this kind of maintenance, can of course be also be embedded into this solution, so that whether it is a plant downtime, or it is a downtime for survey of your vessel, or is a downtime for any of your fleet, which is the best period in the year that we can probably run this maintenance. I'm taking just one more minute because there are two more speakers who are missing. I hope Sinha said that's okay. Of course, we are in a day when we are generating so much of data, and it is important that we consume this data for our own benefit. So what we do is we consume data from operations, we consume data from enterprise, we also consume data on a real time basis from online sources, like it could be social listening, any news item which is important to you. We create these ontologies on our cloud. We have our own cloud called Outscale, where we create these ontologies and data lineage. And then, of course, at the top of it is the dashboards that are created, which helps your top management to see which are the areas of concern or areas that we can be happy about. Of course, the extension of this solution is something that we give our clients on customer analytics. So a large search engine company actually uses our solution to understand what people are talking about them in the open space. So it could be a positive sentiment, it could be a negative sentiment. So it basically tells you what your customer is happy about, what your customer is probably not very happy about, allows you to probably invest capital in those areas of operation which will provide a greater customer satisfaction. So I know that 15 minutes is too less a time to probably cover such a intense topic. We do have a stall in hall number 1. We'll be happy to host all of you at our hall so that we can probably discuss this at length. Thank you so much, and you guys have been a very patient listener. And we are on LinkedIn and other social media where we can catch up. Thank you so much.
Yeah, thank you, Mr. Thomas, for a very interesting presentation. So, we don't have any other speaker right now, but today we had a very good presentation. Mr. Tanu is talking about the Green Port initiative, and Mr. Thomas using of digital technologies for management of marine operations. Very interesting presentations, and they are available after the discussion. You can connect with them and visit the stall of Dassault for further queries, if any. So I thank all the speakers and the audience for their time, and hope to be a part of such panel in future, which is a very important industry, the marine industry, decarbonization, fleet management, and which is the backbone of any offshore operation. Thank you very much. Thank you.